Good afternoon to one and all present here. Now we are going to discuss about what is analog signal and what is digital signal. So that analog and digital signals that can be used in your data transmission system. So that is a basic for your analog, and digital is a basic for your number system and your digital system and all. That is a basic thing. So first we should know that what is a digital signal and what is analog signal. So before that, what do you mean by signal? First we have to know that. So the signal is nothing but actually it is a set of information that can be passed from. It is a set of info. Signal is consist of a set of information that carries the data from one system to another system, and that signals that can be classified as in two types. One is analog signals and another one is digital signals. So if you are taking the analog signals, so the signals are continuous in nature. If you are taking digital signals, that is a discrete signal. That is in terms of an amplitude, it is classified as a analog as well as a digital. So with respect to time, your amplitude of the any signal that can be varied with respect to time, so that is called your analog signal. And what do you mean by digital signal? Means the digital signals or the discrete signals, it cannot be changed with respect to the time. It is having only two forms. One is zero and another one is a one. Zero means high, zero means low, and then one means high. So only in terms of representation is in terms of low or high, or false or true. False means that is a zero, true means that is a one. And how it can be represented means, so analog signals are usually that can be represented in the form of sign. Among the sine wave signal, that will be having triangular wave and sawtooth wave. That will be having so many representations for the analog signals. So with the help of an CRO, cathode ray oscilloscope, we can see that what is the analog representation of the any signal. Similarly, your digital signal means that can be in the form of only the square wave. In the square wave, that is in the 0 and 1. So 1 is nothing but true and 0 is nothing but false. So based on that condition only, we can see that what is an output from the flip-flop. We are going to discuss about in the third unit what do you mean by flip-flop. That is based on only this square wave. And the analog signals in terms of noise immunity concern, your analog signals is affected by the noise, but whereas in case of your digital signal means it cannot that is it cannot be affected by the noise. So here noise is nothing but any signal that can be transmitted from one place to another place. So in that cases, that will be having an through the air only we are going to transmit the signals. So in that cases, we have that unwanted signals that can be superimposed on the original information, so that is called noise. So that noise is more in terms of your analog, but whereas in case of your digital signals, so that is highly immune from the noise disturbance. And the devices which are using analog signals are less flexible, but the devices which are using digital signals are very flexible. Why it is so like this means, because your noises and all, that is already we know that that is very high if it is in case of your analog signals. So in that cases, we are using filters, attenuators, as well as your high pass or low pass filters. Whatever it may be the case, we must use along with the analog devices. Then we can't easily reconfigure the devices. But whereas in case of your digital devices means that is highly flexible due to the noise immunity feature. And digital signals have a high cost, but the analog signals have a low cost. And next one is examples of the analog signals are the voice, human voice, and then your analog thermometer. So these are all the examples of analog signals. Similarly, your voltmeters and ammeter reading with respect to the time and change in input. So these are all nothing but the examples of analog signals. Whereas in case of in your lab sessions and all, cathode ray oscilloscope out, that is also an example of your analog signals. And digital signals means your out from the computers, CD, DVD players, and then digital thermometer. So these are all and all the examples of digital signals. So next class we are going to discuss about the number system conversion. Thank you.